So let us evaluate this in double integration. Now, if you intend to evaluate this double integration, the very first thing that you will be doing is what you will be looking at the inner integration limit. Here, inner integration limit is in terms of y. It is in terms of y. It indicates that it is limit of which variable? X variable. Obviously, if inner integration limit yes is a limit of x, outer integration limit will be limit for which variable? Y variable. Therefore, what we can directly write, the limit for inner integration limit is for x is equal to cube root of y to 2 and y is equal to 0 to y is equal to 8. Okay. Now let us first check whether evaluation of double integration is possible with respect to given order. What is given order? First integration is to be carried out with respect to which variable? X, and then it is to be carried out with respect to y. Okay, but yes, let us see the possibility of evaluation. Okay, so if you want to evaluate with respect to x, what is the integration? It is under root of 1 plus x raised to 4. So I am taking inner integration only. Okay, let us see the outer integration later on. So inner integration is what? Integration from what? Cube root of y to 2 what, and integration is with respect to which variable? X variable. Okay, so I have taken this, and dy is outside, dy is outside here, it will be dy is here. Okay, so dy will be here, and that outer integration from 0 to 8 will be here. So let us check with this possibility of evaluation of integration is possible or not. So you will observe that evaluation of this integration is impossible, it is difficult, even it is impossible. And therefore, what with given order of integration, even though the question is simply evaluate, but the hidden question is actually change the order of integration and evaluate. So for this problem, what we cannot use given order, that is dx dy. Okay, therefore here yes we require the change of order of integration. So how to change the order of integration? So for changing the order of integration, again same thing, write that what which four curves bounds a region of integration, as inner integration limit depends on which variable y, therefore it will be limit of which variable x. So write that the region of integration is bounded by x equal to what? Cube root of y, then x is equal to 2. Okay, x equal to 2, and then what? Y is equal to 0 and y is equal to 8. Okay, so we have written that y is equal to 0 and y is equal to 8. So region of integration is bounded by 4 curves. Let us recognize one by one what these curves are. Okay, note that y is equal to 0 is equation of x-axis, y is equal to 8 is what? Parallel to x-axis at a distance 8. Okay, so this y equal to 8 is again parallel to x-axis at a distance y is equal to 8, and what? X equal to 2. Note that x equal to 0 is equation of y-axis, so x equal to 2 will be parallel to which axis? Your y-axis at a distance x equal to 2. Now the only thing that you need to recognize is this curve. Which curve? X equal to what? Y cube. Sorry, x equal to cube root of y. So x equal to cube root of y can be written as what? X equal to y raised to 1 by 3. Cubing both these sides. So if we cube both these sides, what we get? We get x cube is equal to y. Note that this curve is neither symmetrical about x-axis nor symmetrical about y-axis, neither what it is symmetrical about y equal to x nor symmetrical about y equal to minus x, but you will find that it is symmetrical in opposite quadrant. Why it is symmetrical in opposite quadrant? If you replace x by minus x and y by minus y, yes, we found what that what negative will be outside, negative will get cancelled. So we have same equation of curve by putting x equal to x, y equal to y, x equal to minus x, y equal to minus y. Therefore this curve is symmetrical about symmetrical in opposite quadrant. If x is 0, y is 0, if y is 0, x is 0, if both are 0, again 0 0. So you will find that this curve passes through only origin, and tangent origin is the lowest degree term equated to 0, that is y equal to 0. Y equal to 0 means your x-axis. So x-axis is the tangent at origin. So what is happening here? So this is your what? X-axis, that is your y-axis. Okay, so this curve passes only through origin. This curve passes only through origin. This is the point of contact, and there is only one single point of contact. At this point there is a tangent, and I think already I told you tangent should be as small as it can be. So what we are now drawing a tangent. Yellow is a tangent, red one is a point of contact. This curve is symmetrical in opposite quadrant. We have tangent like this, and you will find that curve is absent. What, there is no asymptote parallel to x-axis, no asymptote parallel to y-axis, and you will find that what curve is present in first and third quadrant, it will be absent in second and fourth quadrant. Why it is present in first and fourth? Because negative here, that gives you negative, and negative will get cancelled, we get valid thing. Okay, if what we have one negative other positive, that is x is negative y is positive, or vice versa, y is negative x is positive, in that case we get a contradiction, that one side is positive other side is negative, that is contradiction. Therefore curve is what, absent in which quadrants? So curve is absent in what, second and fourth quadrant. So curve is absent here and curve is absent here, and that's why what your curve will be, if you draw it with the free hand, yes, your curve will like this: tangential region and there is no asymptote, and tangential region, there is no asymptote, and it is symmetrical in opposite quadrant. Okay, so you can see the most difficult was the curve was depicted over here, and remaining what curves are very precise. Okay, let us go for sketching that curves. So first curve is that x equal to 2. Where is x equal to 2? It is a straight line. X equal to 2 is parallel to y-axis. Okay, so x equal to 0 is here. Okay, this is your x equal to 0, and suppose that this is your x equal to what, which curve? X is equal to 2. Okay, now you are supposed to recognize where is x equal to 8. Okay, so for that, okay, even what we have this curve, which curve? Y is equal to 0. Where is y equal to 0? This is your y equal to 0. Okay, so see, the previous things were for tracing the curve. Okay, and now we are starting with what, you are recognizing your region of integration. So for that, let me clear all of the things, and now what, let us sketch what, all four curves. What is first curve? Okay, let us start with this 1 2. Okay, so let me have x-axis, y-axis, and then just now we have seen what is shape of this curve. So it is a curve like this, one hand above, other right hand above, left hand what, in lower side. Okay, and then the next curve is x equal to 2. Where is x equal to 2? X equal to 2 is parallel to which axis? Your y-axis. So this is your x equal to 2. Okay, so this is what, y is equal to x cube, that is x equal to cube root of y, and second curve is what, x is equal to 2. This is x equal to 2. And next curve, what is next curve? Next curve is y is equal to 0, and y equal to 0, you know, y equal to 0 is here. This is your y equal to 0. Okay, it would be better if you draw a straight line. Okay, so y equal to, here is your y equal to 2, and now the only thing that remains is what, where is y equal to 8? Okay, whether y equal to 8 is here, or it is passing through common point of contact, or it passes through what, the two different, cutting two different curves at two different points. So what is happening? So for that, for knowing that, yes, you solve the equations. Which equation you solve? Okay, solve the equation of what, x equal to 2. If you put x equal to 2 here, you will find that what, 2 cube. Okay, so here is your x equal to 2. Okay, let me write here, this is your x equal to 2. X is, so this is your x equal to 2. So this is your x equal to 2, and this is your y equal to x cube. If you put x equal to 2 here, we get 8. So y is equal to 8. So what is the point of contact? So this point of contact, number 2 point of contact, this one. Okay, so what is this point of contact? So this point of contact obviously will be, what it will be, x is 2 and y is equal to 8. Now it is very easy to recognize where this curve passes through now. Okay, so this curve y is equal to 8, y equal to 8 passes through the common point, that is number 2. Okay, so let me draw a straight line, okay, passing through this point of contact. Okay, so suppose that this is the point of contact, and what first curve y equal to 0 is here, y equal to 0. Okay, now there are so many options and confusion whether this is the region of integration, this is the region of integration, this is region of integration, this is region of integration, this is region of integration, or this one. Okay, so for that, okay, so let me first of all give the numbering: region number 1, region number 2, region number 3, region number 4. Okay, so note that here, okay, region of integration is in between two pink lines, y is equal to 0 to y equal to 8, because initial curve or initial integration, first integration is to be carried out with respect to x. So strip is parallel to x-axis. If a strip is parallel to x-axis, the strip will be like this. Okay, so strip will be like this, and that strip will move. So let me have that strip. So this is your strip. Okay, and this strip moves from first pink line to second pink line. While its motion, yes, one end will be on left side, other end will be on right side. So that will decide your region of integration. Okay, already I given you the options. What are the options? Okay, option number, what we have? Option number 1, 2, 3, 4. Because region of integration will be between two pink lines. It will not be above second pink line, it will not be below first pink line. Okay, it will be in between two pink lines. So whether it is region number 1, 2 or 3 or 4, that will be decided by what? The strip. Okay, now let us move the strip and let us see where the ends of the strips are. Okay, so I am going to move now the which strip? Yellow strip. See, yellow strip is moving. Okay, see how it is moving from bottom to top. So this is the initial position, and it is moving in upward direction. So its starting position is y equal to 0, and its ending position is y is equal to 1. Okay, y is equal to 8, not y equal to 1. Y equal to 0 is here, and y equal to 8 is here. Y equal to 0 to 8. So it is moving like this. Okay, from bottom to top, it is moving from bottom to top. While its motion, okay, this is the arbitrary position. While its motion, where is the left end, or what you can see lower end? The lower end is on what? X equal to cube root of y. Note that x equal to cube root of y is nothing but what? Your curve y equal to x cube. Y equal to x cube and x equal to cube root of y are equivalent. So left end is here. Okay, where is left end? So left end is on yes, y equal to x cube, and right end is on which curve? What? X equal to 2. So x equal to 2. So what this suggests that, okay, pink region number 3 is correct region of integration. Okay, so what you will be doing? Yes, you will be sketching that one. Okay, so I am going to remove all of these. So this is your region of integration, correct region of integration. Now what we are supposed to do is what? Change the order of integration. So initially the yellow strip is parallel to which axis? X axis. Once we change the order of integration, the strip becomes parallel to which axis? Y axis. Okay, so its actual figure is here. Okay, so only this part is shown. Okay, this part is shown, you can check it out. This is your x axis, y axis. So this part is not shown. Okay, let me clear out all the things and then we will discuss. Okay, so if you change the order of integration, the strip become parallel to which axis? Y axis. While its motion, Okay, so this strip which is parallel to axis, yes, it moves from left to right. Now the next strip that is parallel to what y axis, it will be like this. So that strip moves from this point because it is starting of region of integration. So it is moving from what y axis, what is y axis, x equal to 0. So it is moving from x equal to 0 to x equal to 2. Note that this point of contact is x equal to 2, y is equal to 8. So it is moving from x equal to 2 and y equal to 8. It moves like this. Okay, the strip moves like this. Okay, while its motion, where is the lower end? So this strip is moving like this. This strip moves from left to right. So its extreme left position is here, and its extreme what left position is here. So it is nothing but x equal to, and this is nothing but x equal to 0. That's why my limit becomes what, x equal to 0 to 2. You can check it out. My limit is from x equal to 0 to 2. Therefore I written what, limit for x varies from, limit of x varies from 0 to 2 while its motion. Now what is happening? See, where is the lower and upper end? Lower end is on x axis. What is the equation of x axis? Y is equal to 0. So equation of x axis is y equal to 0. And even you can observe over that, once we got limit of x, which limit is remaining? Y limit is remaining. So lower end of the strip is on x equal to 0. Y equal to 0, that is equation of x axis. So lower end is on y is equal to 0, that is x axis. Upper end is on y is equal to what, x cube. And that's why my new limit, yes, becomes what, 0 to 2, x from 0 to 2, and y from 0 to x cube. So obviously this will be the outer integration limit, and this will be inner integration limit. Always remember that outer integration limit is constant. If you got constant, means it is outer integration limit. If both are constant, in that case any can be outer integration, any can be inner integration. But if one is variable, other is constant, outer integration limit always will be a constant. That's why this integration, after changing the order of integration, becomes 0 to 2. 0 to 8 becomes 0 to 2, 0 to 2 and 0 to x cube. And integrand is same, what, under root of what, 1 plus x raised to 4, what, dy dx. So in place of writing dx dy, yes, you should write dy dx. Even if you write dx dy, it is immaterial. While integrating, we will take obviously x terms outside. So first integration is to be carried out with respect to which variable? Y variable. Therefore under root of 1 plus x raised to 4 will be what, outside along with dx. Okay, but it is inside outer integration. So what remains inside inner integration? Only dy, and integration of dy is what, y. If you put upper limit, we get y cube, and if you put lower limit, we get 0. That's why our answer is y cube. Okay, and y cube for y, if you put x cube, yes, we get x cube minus 0, that is x cube. Okay, now 0 to 2 x cube under root of 1 plus x raised to 4 dx we got here, and this integration is what, your ordinary integration. Okay, and this can be very easily integrated by putting either x raised to 4 equal to t, or by putting what, 1 plus x raised to 4. Both substitutions are correct. In that case we get simply under root of t, and integration of under root of t is t raised to half what, plus 1, that is 3 by 2 divided by half plus 1 divided by 3 by 2. So we get what, t raised to 3 by 2 divided by what, 3 by 2. Put upper limit, lower limit, yes, you get this answer. I hope that what you got the concept of evaluation of double integration by first problem.